Hello, everyone. So yeah, we'll be talking about doing releasing an iPhone game using Scaleform as a full 2D engine. Scaleform is more known as a UI engine, but we used it as a full 2D engine. So as an homage to the artist, I thought I would do the presentation in black and white and as a silent movie. But maybe not. But more seriously, that shows that 2D, it's a switch from 3D to 2D. So I'm the co-founder of GlobZ. It's a French studio that started in January 2000. So over the years, we've done a lot of Flash since the beginning, like Flash 3, 4, 5, 6, 7, 8, 9, 10, 11. We've also done, we've also used some other technologies, which is always interesting to compare. So we've used Java for mobile, G2ME, just for prototypes, not for real games, not for games that have been published directly. We've used MobiClip, which was a vector engine that was acquired by Adobe at some time. We did a Nintendo DSiWare game in-house, so it was really completely different, a console experience. We did some iOS native games. By native, I mean we've chosen to do C wrapped with a little Objective-C, but not too much. We've done some Unity, a Unity game, which is interesting too. And most recent is Scaleform. So rapidly, this is previously we released a game called GlobZ, which is a collection of mini games, and we got some prizes for it. So first, I will try to explain why mobile and tablets are strategic and what new topics and issues they raise in terms of games, technological and not only technological. So let's do some quiz. So what is the platform that sold the most units ever, the gaming platform? It's the PS2 that sold 153 million units. So here you have the overall top 10 ever. And so the PS2 sold 153 million since 2000. iOS devices, they shipped 156 million in just 2011. So there may be a kind of shift there. So, and iOS since the beginning, it was June 2007, it's 316 million, which is more than PS2 and DS combined. So it's kind of a huge market. And it's just the beginning because I just mentioned iOS figures. Oops. And you also have Android. And smartphones are just 30% of the market now, so it's still expanding. Tablets, I've put links all the time, but tablets are going to oversell PCs in 2013. So mobile, it's big in numbers. It's fragmented. I like this image. The quality is not really good. It comes from Google. So if you type before and after the iPhone in Google Images, you get this. So that's interesting because you see the fragmentation. Like before, it was you had a lot of different devices, like with keys on the sides. Like, can I? No. With the one on the left has keys. The key pad is round. Some have the keys on the sides. And now, after the iPhone, everything is touch-based, but you see a lot of different screen sizes. So now mobile is pretty much touch-based. That's very important too. Mobile has a lot of different screen resolutions. Here you can see it. It's almost always the same, but never exactly the same. And this is just mobile. It's not tablets. Tablets, it's even worse. You have also to always remember that mobile is limited. It's not like a full PC. So basically, mobile use is different. It's a 2D, more of a 2D world. These are the most popular games on mobile. As you can see, like this is the top 25 all-time paid apps on iOS. And you see only 2D games like Angry Birds, Fruit Ninja, Doodle Jim, Cut the Rope, Plant vs. Zombie, Tiny Wing. It's all Fly Control and Where is Wally? It's all 2D games. So 2D in mobile, it's really important. So to sum up, mobile is big, fragmented, it's touch-based, it's have a lot of resolution, it's limited in terms of power, different use, and it's 2D. So you have to adapt the gameplay to all that constraints, all that limitations. That's what we did with our game. So this is the splash screen. It's available in the App Store. You can search for TwinSpin, and you'll get it. It's 99 cents. And so basically what we wanted to do is a game that you play with just one button. So you don't have to adapt like with the controls to every situation. Like the simplest is the better in that case. So I will show you rapidly a quick trailer of the game. So there are a lot of actions you can do by just tapping. So there are 72 levels. Yeah, it's going to be said just after. So everything runs with a Scaleform. It's available on the App Store right now for iPhone for the moment, but the iPad version should be available soon. And as Scaleform is all about vectors, it's going to be easy to go from iPhone to the iPad. So basically, there are a lot of opportunities in the mobile world, but the choice of the right technology of our engine is really key. So I will show now the game running on iPad, so you can see it already runs. And I'll show what Scaleform offers. Offers some really nice controls over the game you're running. Like on the top left, you see, so here, Scaleform, at the beginning, it's the core goal of Scaleform is to do UI, so you can see we did a nice UI with transitions and nice effects. To do that in native code, it's really painful. So here you can slide and everything. Everything is smooth and really dynamic. We've done iOS native games, and to do that natively again, it's a lot of work, and it's really boring work. So here's the game running. And you can see on the top left, you have what at Scaleform they call it the HUD. So then you open it while the game is running, which is nice. And then you get a lot of information, for example, the frame rate. So you can see here, we're running at 60 frames per second, which is the standard in terms of native games. They run all at that because then you synchronize with the device display. So when we ported the game, originally the game was 25 frames per second, but with Scaleform we could go up to 60. So here you see you can toggle on or off the anti-aliasing. You can see the memory the game is using. So here the anti-aliasing was turned off. So for some sequences, like a transition or a heavy explosion or something like that, you can toggle the anti-aliasing, which is the way the engine renders curves really nicely, smoothly. So this is very useful. So basically, Scaleform is vector-based. A vector is, so everything that is drawn on the screen is based on computation compared to a bitmap where it's just a texture that is drawn on the screen. And what is nice about vector is that they scale, like you can, like it's the same file that runs on the iPhone and the iPad. It just scales up without any visible thing. Scaleform, its core function is to do UI. So it's all the integration with Xcode is really nice. Here you can see it's an Xcode project. You can see the Swift file is embedded into that environment. Here you find your usual plist where you put all your parameters for your application. And here you see this is Objective-C code, so you can communicate between the Flash file and Objective-C through Scaleform, back and forth. You can call functions in Objective-C. So Scaleform is all about control. One of the greatest features we've liked using Scaleform, it's that it's really fast to compile on the device. And when you do a mobile game, it's really key to test it on the device. When you have a solution where it takes like a few minutes to go to the device, you don't do it as often as you should. And then when you come back to the device, the game is not as smooth as it should be because you stop testing it, so it's not good. So like here, it took less than 30 seconds to go to compile the Flash plus after to go on the device, which is really fast compared to other solutions. Scaleform, what we found is that it's very ActionScript compatible. We found no issue with our code that was done before, which is really important because usually when you work with one of these technology, you have to go step by step and make sure your code is still compatible. And usually when you take a project from the past and you want to output it, you have a lot of errors and you have to go back and everything. And here we had our code base and it just ran on Scaleform directly. I'll skip that one, but it's about HTML5. But so why? I'll speak a little about why Flash is great, but Adobe seems to do go somewhere that is not like the roots of Flash, and in a way, Scaleform is doing, in our opinion, a kind of better job to be like on the Flash stream. So Flash is basically this is a capture of the Flash environment, and it's basically a graph. It was at first it was animation tool, like 2D animation tool, and like some people that do native code, they would die to have an environment where they can, like, this is a level from the game, and so you can like graphically put all your interactors, and then not only that, usually in studios they do like level editors and stuff, they have to develop tools. So for us, Flash is a great 2D tool to do simple and 2D games. And here, if it's not even, sorry, it's a video, I have to click on it. So it's not even like a static level editor, but you can animate elements of the game, like by using standard animation, like twinnings. And here it's built in Flash, like you have easing, like it's faster at the beginning and then it slows down. If you have to do that by code, it's a lot of work. And so Flash is a great tool to do that. And another great feature of Flash is the nested movie clips. And on Sunday I was at the Flash Gaming Summit. I've put all the videos are accessible there, and everybody kept saying that that Flash thing where you can have a displayer, and inside you can address other boxes like a face. You can have the eyes and the mouse, and for a character it's really powerful because then the mouse can move independently of the head and the eyes can blink. So I have a little example to show what are so see it's vector, so up it scales up. So here you have a character, and basically you can change independently all the animations, like the arms and stuff, like he's waving, he's doing something else. So this is it was done in Flash 3 a long time ago. It looks simple, but it's very powerful. And with So now I will speak a little about Scaleform versus all the tools we know, which is interesting to benchmark and see strengths of all the solutions. And so it seems that the latest version of Adobe Air, which is 3.2, it's all about bitmaps, which is kind of strange for Flash, because Flash, the ground foundation of Flash is all vectors. But for performance issues, Adobe is going to in the bitmaps way, I would say. So it's all about having sprite sheets. So instead of having a character like I shown you, where you can combine everything, you have to have all the animations, like the strips, prepared. For us, it's like something from the past, like it's a back to native code where you have to do all PNGs. What we found about Scaleform on the left is AES1 or AES2, AES3 can benefit from the GPU acceleration just by dropping a Swift file on the Scaleform engine on your PC. It runs faster than with the Flash player. And directly, without any code modification, you're benefiting from GPU, sorry. So GPU is the graphic card. So the Flash file is not run by your processor, but it's run by the graphic card. And the result is that it's faster. And like the latest Adobe Air, again, 3.2, it's they use a new API, they call it Starling. To benefit the GPU acceleration, you have to use a new API, and it's not regular ActionScript code. So basically, you have to, before that, you had to rewrite your games from AES2 to AES3, and then you have to rewrite AES3 to Starling. But with Scaleform, even an AES1, AES2, AES3 game still can benefit from the GPU. The footprint on mobile, it's smaller for Scaleform. It's 6 megabyte compared to 9 megabyte. Apple just announced yesterday that they would raise the limit to the download over-the-air limit. It was 20 megabytes before, so this limit was really important. And now it's 50 megabyte, but still, it's good to have a small footprint, so you have more space for your game. And again, with Scaleform, you can still use Flash Pro, which is the graphic environment I showed you. With Starling, you have to work with Flash Develop, which is a side tool, and you're using an API that is not from Adobe, so it's kind of strange, but they're changing tools, so it's not really good for your workflow, because you have to change your tech all the time. Another one that is interesting also is to compare Scaleform versus X. It's pronounced X Enemy. You can find info on xenemy.com or org, I think. I forgot to mention it. But again, it's not regular AES3, and then it's a kind of mix between Flash and native code. You have to do all your assets in PNG, and it takes a lot of time to do that when you have animations and everything. And when you have a change, like yesterday, somebody that does UI mentioned a change of a button and everything, then you have to copy and paste your modifications in Photoshop. It's really long. And then you have a lot of new technologies that are coming out, like Spaceport, I/O, particle code, OpenPlug. But what is interesting is that, for example, the two particle code and OpenPlug have been acquired recently. So it's kind of a bet, and it's kind of a risky bet for a small or even larger studio to bet on emerging technologies. And so Scaleform has been running for a few years, and it has been acquired by Autodesk recently. So you can bet on that Scaleform will be running. So it's interesting that you can bet on a real reliable technology. And lastly, it's kind of weird to compare a 2D engine versus a 3D engine, but you have a lot of 2D games that are done with Unity on the iPhone. Like on the iPhone, maybe 80% of the games made with Unity are done are 2D games, like games with physics and puzzle games. So, and we've used Unity, but it's kind of always strange to use a 3D tool to do 2D. You have always to do tricks and everything. But I know that there is such a demand, they're working on it, but it's not still ready. So, and I'll end up with some tips we've found when we were working with Scaleform to optimize and everything. Like, basically, the code is not an issue. like for simple games, like the game we did is not a very complex game. There is no AI running calculation and stuff like that, but you have collisions and stuff. But so basically, the code is not an issue. Vector rendering, it depends a lot on the size, and we cannot wait to have the new iPad, which has Retina resolution, and the same build should run directly in the new Retina resolution of the new iPad. But still, we have to verify the frame rate is still 60 frames per second all the time. Because when you double the size, you multiply the surface by 4, so you have to. It hits the processor 4 times more. So what we found something funny is that because of constraints on the, but it's usual constraints when you do native code, your bitmap have to be on a 8, 16, 32, 40, 64 grid. So in Scaleform, in Flash you do a bitmap that is maybe 10 pixels wide, Scaleform scales it back to 8 because it's much faster. So it's kind of funny, but you have to know it, so you prepare your asset. And what we found also is that to optimize, you don't want to pile up a lot of assets in the same part of the screen. And lastly, and it's an echo of one of the first slides, which says that mobile is very limited. At first, we used MP3 encoding for the sound of our game, and when a loop sound would load, the game would stop for a second, and we're like, oh, this is really bad. And then we switched in Flash to ADPCM audio codec, which is also supported. And then it was really fast. And it's just the beginning of the Scaleform tips, because it was kind of an experiment. We had a really nice relationship with the Scaleform team, exchanging on features and everything. But it's we're one of the first studios, and we hope that there will be a forum, and we'll share all the tips with the other developers. So if you have, this is my contact if you have questions. Oh, oops.
Thank you very much, Alex.